We're looking at Lab 5, the second part for network analysis. This is EEE 117. And to do this, we are going to go into our virtual desktop because I don't have PSpice on my computer. So we're going to use the schools. We have Cadence release, and then we're going to go to Capture CIS. We're going to have Allegro PCB design. Click OK. And then this bad boy will pop up. From here, what we're going to want to do is make a new project because we are creating a new project. We'll call it Lab 5.2 because it's the second part. We want to make sure PSpice analog or mixed AD is selected. We want to choose our location. I'm going to save it to my drive and then to my desktop and then to the Lab 6 folder, which I will change to Lab 5.2 when I'm done with this. So we're going to press OK, and then we're going to press OK here, and the project name is invalid because we can't have a dot in there. So we'll just name it Lab 5, and we'll press OK. We want to create a blank project, and then we're going to press OK to this. Our PSpice is going to load, and now we have a blank kind of paper like this. So to make our circuit, there's a few things that we need to do. First, we have these parts in our library. And we need to get all these parts, so we're going to highlight, select them all, and click Open. Now from here, we can build our circuit. Now our circuit is going to look like the picture that I hopefully have edited in when I'm editing, but we're going to make this. So to make this, we are going to use an opamp. We're going to use the opamp UA741 and press Enter, and then this will give us our opamp here. Now we're going to zoom in, and we can see that we have a positive over a negative, but we want a negative over a positive, so we're going to mirror vertically, and this will flip it vertically. From here, we're going to want to add some of our circuit components. The first thing that I'm going to do is make the bottom left. So we can see that we're going to need some resistors. I'll just type in R, and then this resistor will pop up, and it'll give us a resistor here. We'll place a resistor here, and then we're going to also place a resistor here. And then after this, well, we want a resistor kind of down here. We're going to flip it in a second. And then we want two resistors up here. Now, in the picture, it says R not plus delta R. But that's okay. We can have two resistors in series. And if they're in series, we know we just add the resistors together. So it's okay for them to be like this. Now we're going to come over here. We are going to rotate this. So this is R3, and then we have our value right here. We're going to change the values of these resistors according to the lab. These are the theoretical calculations, but we want the experimental ones because those are accurate. They're more accurate. And so now from here, we need, what the hell? Now from here, we need an initial voltage, so we're going to do V. We want a sine voltage, so we're going to do V sine. And then we're going to place this over here. And then from here, we also need some grounds. So we're going to click the ground and click this symbol. We're going to place this here. And then we're also going to place one below here. And now we can just wire these up. So we'll have a wire going here, 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 and then this resistor will connect in here, and then this resistor will connect in here to this ground, and then it's going to connect in here. So we have our entire left side built. Our V offset is going to be 0 volts. Our V amp, this can be found in our actual lab document that we're doing, so the calculation for this is 2 volts. And same thing with the frequency, it's going to be 500 hertz. So we'll just write in 500 hertz, and then we're going to leave the AC blank. Now this resistor right here we want to change to be 1.95 kilo ohms, so we'll just do 1.90, not 9, we want 1.95. And then for this one right here, it's going to be 1.95 kilo ohms as well, because these are actually the same exact resistors. So they're measured the exact same, but we do have to have different labels for them. Now from here, what we're going to want to do is we're going to take a look at these resistors, and we're going to connect them to the output of our op-amp. So we have the op-amp, output goes like this, goes back here, and then we love our negative feedback, so it's going to go through here, and then back this way. Now we need to do one more thing, and we need to add two voltages. And this is going to be a VDC. We're going to have voltage here, and then we're going to have voltage here, and they're both going to be connected to ground. So we click the ground placement, and we're going to place this here and here. Now we need to rotate all of these. And we're going to rotate, you can see that we have a negative with the actual part right here, and then we have a positive with the actual part right here. This needs to be on the same side as whatever is right here. So the top part, we see we have a negative up here, so we're going to rotate this, and we're going to have to rotate it 3 times, that way the negative is with the negative here. Now we want to rotate the ground as well. The ground is going to face this way, and then we're going to do the same for this one, except we only need to rotate it once because we have the plus on this side. And now we can also rotate this ground right here. So this is what our circuit's going to look like, and we can line them up so it looks nice. Then we're going to want to connect all of these together. And per the lab calculations, we're going to have 5 VDC inside of here. This is going to be a negative 5 VDC, but this negative out here already takes care of it. And then we have a 5 VDC down here. And so last thing we have to do is just change these. So per the lab, we have 0.996 for this actual resistor. And then this one is going to be not a specific value because we're going to have multiple deltas inside of here. We have a delta R right here. And so we have 3 different actual values. So we're going to replace this with just a delta R like this, and then we're going to press OK, leaving everything else unchanged. And so this is going to be our circuit diagram. Now we want to go up to place, and then we want to place a net alias. We're going to make a V0 for the output, and we need to connect it to this wire right here. We need to go back up to place and then net alias again, and then we're going to have V and then a 2, and this is going to be our input over here. Now we have this delta R, and if we were to run it like this, it wouldn't work properly. What we need to do is we need to come up to our part and do param, and then our parameters will pop up right here. We can click enter, and then this parameter box will come up. We'll double click this, and then this list will pop up, or it'll look something like this. But I'm just going to make it look like this. From here, we want to click new property. We'll just click yes to this. We want the name of our property to be the same name of our resistor, and this is the delta R. And then our value is just going to be 1. Because we have 3 different values, we're just multiplying it in by 1. We're going to click apply, and then click yes, and click OK. And actually, we shouldn't click OK, we should just close this. And so our delta R is just 1 here. Now we go back to our page 1, and we have this here. We want to run our simulation, so we're going to click new simulation profile, and we'll just click lab 5 and click create. From here, a little window on the bottom should pop up. We're going to click Allegro PSpice simulator, and then this is going to pop up. In the lab, we have a transient analysis from 0 to 3t, where t is the period. We know period is 1 over the frequency, so we're going to have 1 over 500, but this is times 3 because it's 3t. So basically we have 3 over 500. And so this is going to yield 6 milliseconds. So we're going to come up in here, and so the total runtime is going to be 6 milliseconds. The maximum step size is going to be the total runtime divided by the number of steps. And so this is going to give us 12 microseconds. So we're going to have a US in here. We also want a parametric sweep. And this is because we have multiple values. So we're going to be in here now. We want to change this first part from voltage source to global parameter. And our parameter name is delta R. And our value list is going to be the delta R's that we measured. So this is important to measure out. This is going to be the experimental value, and again, not the theoretical value. So we have 3 of them. We're just going to put these in as 0.196K. We're going to separate this with a comma, no space, and then we're going to have 0.988K, comma, no space, and then 4.58K. We can click apply and click OK, and then we just want to click run. And then this will load out, and then we will have our values pop up. And so these are our approximate values. They might be a little bit different depending on the resistance, depending on the actual values that we have for our delta R, but they should be similar to this. And now from here, we can open this bottom window and we have a schematic right here. We have all of these and we want to make sure they're all selected, and then we can press OK. And so our graph will pop up here. If it's black, it's easier to see in white, so we can go up to Tools, Options, Color Settings, and just change the background. Now we want to trace. We're going to click Add Trace. We want to unclick power and unclick currents because we don't need those. We only want voltage. And so we know that we have V2. That's our input, so we're going to click OK in here. Now we want to click this and click Trace Property. We can keep the color, but we want the width to be a little bit bigger so it's easier to see. And so this is our V2. We'll go back up to Trace, click Add Trace, and we want to now add our V0. So we're going to have to find our V0, which we do, and click OK. And now we can see multiple things have popped up. We're just going to go into Trace Property. We want to make the width a little bit bigger, and then the same thing with this one. Trace Property, and then make this width a little bit bigger as well. And then we have this other trace in here which is super hard to see. It's right in this lower part, and then we can click Trace Property, and then we're going to change the color because I can barely see it with my blue light filter, and then we're going to change the width, click OK, and now we can see it. And so this is our graph. This is the output of our graph, and then this is our simulation. So we would take pictures of these and then write descriptions for them both in our lab. And that's how you do this part, setting up the PSpice simulation and also the graph for it.